So before we get too far, I want to mention, obviously, there's a couple of homeworks due tomorrow, the 2-0 through 2-2, and 2-3 through 2-4 are stuff we covered this week. The bonus homework as well, the 1-6, 1-7, that's due tomorrow at 5 as well. So there's 3 homeworks due tomorrow at 5. One is this one, bonus homework, and the other 2 are these 2. We've basically covered the vast majority of 2-2, or at least all the calculations you need. And then we'll do 2-3 and 2-4 today. Those are pretty quick chapters. So let's go back to our interest comparison calculations we were doing earlier. So remember, we are doing interest calculations with what I call a lump sum formula. That is, we put in a specific sum into an account of some type. That lump sum, that money value, is called the principal. And it gains interest over a certain time period. The amount you're going to have at the end is calculated by taking the initial amount, the principal, times 1 plus rate over m to the mt power. Remember that m is how often interest is compounded per year, and the t is going to be number of years. Okay. So we've done a couple of examples. We saw that when we compound monthly versus quarterly, for instance, that there is a little bit of difference. The more often you compound per year, the more we're going to have at the end. But it's not a gigantic difference, right? So monthly gained more interest than quarterly. Quarterly would also gain more interest than yearly, but it wasn't a gigantic difference. Then we saw what happens when the starting amounts were different. And we calculated what's going to happen if you input $2,000 versus input $4,000. And if you input twice as much, you gain twice as much interest. And if you input twice as much, you're going to get twice as much out. And the same thing with any multiple. If somebody inputted 10 times as much as I did, they're going to get 10 times as much out. That's what we calculated last time. This time, we're going to change the interest rates, and then we'll change the time. So here's what I'd like you to do for example 3. I would like you to do the first 2 bullet points on your own. Figure out how much is in the account after 15 years, and then decide how much interest is gained in those first 2 bullet points. You don't have to do the 3rd bullet point. It's pretty redundant. All right. So let's do both of these. People are doing well on that. Got a ring tag it. So we have A equals P times 1 plus R over M to the MT. That's our formula. If we're in that first bullet point, the principal is $2,000. That's our starting amount that I input. The rate is 4%, so that's an R of 0.04. We're compounding quarterly, so we're dividing by an M of 4. And then the exponent is going to be 4 times 15 years. Quarterly times 15 years. When I put that in my calculator, I put that in as a 60 exponent, just to make it easier on myself. And the amounts that this individual will have after 15 years would be expected to be $3,633.39. Now, if you look at how much money was gained, or sometimes that'll be called the interest gain. How much money did we gain on this initial 2,000? Well, we start with 2,000, we ended up with this. So the difference is going to be how much the gain was. And so the amount that was gained is $1,633.39. So this is how much you'll have in the account, and this is how much was gained over your initial 2,000 investment. Now, if we double the interest rate, we go from 4% gain to an 8% gain. Most of the calculations are going to look identical, except for obviously the R changes. So we're going to have a $2,000 principal, 1 plus 0.08. Since we're compounding quarterly, we're dividing by 4. Our M is 4 times 15 years. Again, when I type that into my calculator, I write a 60 as the exponent. And the person who gains 8% interest will have $6,562.06. That means, as far as the interest gain, this person gained $4,562.06 by getting 8% interest. Notice the difference here. Look at the interest gain. While we doubled our rate, the interest gain was much more than double. Everybody see that? Last time we were in here, we saw that if we doubled our principal, it was exactly double the interest gain. But here, doubling the rate actually more than doubles your interest gain. So that's a big difference. That rate, therefore, is really, really important. Now let's do the last comparison. And this is going to be a comparison where our time differs. So I just want you to do the first 2 bullet points in example 4. If you have time, you can do the third as well. But we'll invest $2,000 again here at 6% interest compounded yearly. One time do that for 10 years, and then on the second time, do that for 20 years. We'll double it. Doubles are pretty easy to deal with. All right, people are doing pretty well with calculations. As we walk around, people are getting the right calculation steps in. So let me get going. If you haven't finished both examples, that's fine. You can obviously go try that third example too on your own if you want. So if we put in $2,000 compounded yearly for 10 years at 6% interest, that was the first bullet point. P becomes 2,000. Compounding yearly means that that M is a 1. 6% interest means my R is 0.06. For 10 years means my T is 10. And again, 1 times 10 is just 10. So I put in 10 into my exponent when I type into my calculator. After 10 years, this individual will have 3581.70. That's 69.5 rounds up to a 70. Okay. That means the interest gained here in the first 10 years was $1,581.70. Now at 20 years, doing the exact same thing, but just keeping your money in there for longer. All we have to switch is our time from a 10 to a 20. Excuse me. And the amount that we end up with after 20 years is 6414.27. And that means the interest gained was $4,414.27. Now, again, let's take a step back and look at big picture of what's happening here. When you compare the interest gain, you went from 10 years to 20 years, so you doubled the amount of time. And notice what you did to your amount. You more than doubled the amount of interest gained. Does that make sense? So by doubling your time, it makes a huge impact on how much interest you gain. By doubling the rate, it makes a huge impact on how much interest was gained. By doubling the principal, it makes a huge impact. And by changing how often you're compounding, it makes some impact, not as big as the other three though. Okay. And that'll work for any amount of change. So here are the big takeaways. If I change how often the interest is accumulating per year, it does change the final amount some, but not a ton. Okay. So if you change the M, it does change the final amount, but not by a ton. On the other hand, if you increase the initial amount, if you increase the principal by a factor of whatever X, so if that X is a factor of 10, or if that's a factor of 2, or if that's a factor of 5, let's just say factor of 10 right now. If you increase by a factor of 10, then the interest will also increase by a factor of 10. And if you increase by a factor of 50, the interest increased by the exact same factor of 50. That makes sense. So if you increase the principal, you get the exact same factor increase in interest accumulated. And then what we saw right now was that if we increase the rate, or if we increase the time by a factor of 10, then the interest is going to be increased not by a factor of 10, but by more than a factor of 10. And if you increase by a factor of 50, the rate or the time, then the interest gained will increase by more than a factor of 50. Now that's all well enough and good. How can we use this in our lives? Well, most people who do retirement planning will give you the following advice. They'll say when you're doing your retirement planning or when you're trying to start investing for your retirement, they'll say do it as early as possible. So start as early as possible. What that means is you're increasing the time, right? You're increasing that T. They'll also say, well, let's get the best interest rate possible. Let's not go bury your money in the jar in the backyard, right? Let's put it in the stock market or probably in pretty diversified portfolio, but let's put it in the stock market or let's put it in bonds or something like that. What that is doing is it's increasing the R. So they're trying to increase the R by putting it into things that will yield some money. And then they'll also often say, well, we need you to put in as much as you can afford. That's an increase of the principal, P. So all they're doing is they're saying maximize your principal, maximize your rate, maximize your time as much as possible in that formula. Okay. Now again, this is, I'm not telling you which stocks to invest in because I don't know tomorrow which ones are going to go up and which ones are going to go down. But I can tell you, if you follow, right, increase your P, increase your R, increase your T, mathematically, those are really good ways to boost your investments. Increase P, increase R, increase M, increase T. Again, M will do some, but not as much as the P, the R, and the T. All right. Everybody okay with that? Interest and doing all those calculations? Feeling good about that? Got more people online today, so which makes sense. It's snowing. It's fun. Or was snowing, I should say. So now what we're going to do is we're going to look at a section called present value. Okay. Present value kind of flips the question that we've been doing so far. So far we've said, I'm going to put in 2,000 now, how much will I have in 10 years? Present value says, I want to get out 3,600, how much should I put in right now? And all we're really doing is we're saying, so far, I've always given you the principal. The principal can be thought of as the present value, and asked you to calculate an A, which can be thought of as a future value. Now we're going to give you the A and ask you to calculate the P. So in my interest equation, that basic interest equation, A equals P, 1 plus R over N to the MT, the present value is just the principal. And when we say future value, that's just the A, the amount. And what I'm saying is in that formula there, okay? So oftentimes people will change this and they'll put PV instead of just P. Instead of principal, they'll put PV for present value. And instead of the A, they'll put FV for future value. I'm not going to do that. I'm just going to keep the P and the A and know that A is the amount in the future and P is the amount in the present. Okay. I don't need new letters. We already have 2 fine letters. So let's do an example. We know we can get 5% compounded yearly. We can get 5% interest compounded yearly. How much would we need to invest now to have $16,000 in 10 years? $16,000 in 10 years. So does everybody understand the scenario? We're saying we want to have 16,000 in 10 years. We need to figure out how much to put in right now. Okay. Now there is a way, and I'll show you that way in just a second, of manipulating the formula. I don't like to manipulate the formula. I don't like to memorize new formulas. So if my old formula works, I'll just use my old formula. Okay. So I'm going to use my old formula. We want 16,000, so that goes in for the A. The P is what I don't know yet. So I just leave it as P. My rate, it says, is 5% over an M of 1, because we're compounded yearly. And then that's 1 times 10. So in other words, 16,000 is equal to P times 1 plus 0.05 over 1 to the 10th power. Oh, hit the wrong thing. Wrong thing again. Okay. Now, in order to figure out what P has to be, this is just a number. So it's exactly like if I said I have 18 equals P times 4. What would you do to find the P? Well, you divide both sides by 4, right? So that's a Math 104 thing. Got algebra, basic algebra. All we have to do, therefore, is divide both sides of this equation by that number. Now, the reason I'm writing it like this, rather than trying to calculate that number and then divide by it, is that this number is going to have some ugly decimals in it. So it's going to be easier to type into my calculator 16,000 divided by, and then in parentheses, 1 plus 0.05 over 1 to the 10th power. And then that will be my P. So that's what I'm going to type into my calculator. Let me show you that. I'll show you that with both calculators, how I type that in. All right, both calculators that we have. There we go. So this is all my earlier work that I was doing. As you can see, I was taking 2,000 times that number. Now I'm going to take 16,000, and then I'm just getting the divide key. And then in parentheses, 1 plus 0.05 over 1 to the 10th power. All right. And so in that type of calculator, the only difference is we're gonna, make sure you have that divide sign. And you should get a number that's smaller than 16,000, right? Because if you're making 5%, you start with something smaller, and then in the future, it's gonna grow to 16,000. With the TI-30, it's the exact same thing. I'm going to take 16,000, and then I'm just going to hit the divide sign, and then in parentheses 1 plus 0.05 over 1 into my parentheses, and then do caret 10. Hit enter. So 9822.61, rounding to 2 decimal places. So the present value of $16,000 in the future is $9,822.61. Now, if you see later in life somebody saying, well, the present value, I use the formula future value over 1 plus R over M to the MT, you'd say, yeah, that's just what we get when we divide both sides by this thing, right? Also, some people will write, take your future value times 1 plus R over M to the negative MT, because dividing by something with an exponent is like multiplying with something to the negative exponent. I don't know if you guys know that or not, but so a negative exponent, if you have, just do like lowercase b to the -1, that's like 1 over b. So dividing by b is like multiplying by b to the -1. So a lot of times you'll see the future value, present value equation written in this version with a negative exponent. Again, I tend not to do those versions because we already have a perfectly fine version right here that we can solve by just dividing both sides by that number. So I think that's a little bit easier. That means I only need to figure out one equation and have one equation written down. This one in particular. Does that work? So there are other equations that people do, and it's just manipulations of that. That's all. All right, I want you to try this one on your own. We know we can get 11% interest compounded monthly. How much would we need to invest now to have $25,600 in 20 years? Perfect. All right, people are doing really well on this. I'll keep moving along. In this case, we want to have $25,600 in the future. We want to know how much to invest now to have that. We can get 11% interest compounded monthly for 20 years. In this one, I'm kind of particular about always making sure I multiply this out when I write it into my calculator, just so I don't have any mistakes. 12 times 20 is 240. That's something you can just type in on your calculator. 12 times 20 is 240, and then put it in there. And then we divide both sides by 1 plus 0.11 over 12 to 240. Divide by 1 plus 0.11 over 12 to the 240th power. Okay. And we get a present value of $2,865.13. By the way, this shows you the power of this compounding interest. This is telling you if you start with like $2,865, in 20 years, if you invest it at 11% interest, in 20 years, you can get up to 25,000. That's a pretty big jump, right? That's a really large jump. And 11% interest is a high interest rate, don't get me wrong. Very high return, but you can see the power of this compounding interest. It really can grow money if you let it sit for a long period of time. Okay. Or if you let it to gain interest for a long period of time. Let's try one more. Try to do this one on your own as well. Go ahead and read that and then do that on your own. All right. So let's do this. This will be our last one in this section. We have an amount of $200,000 we want in 30 years. So we're going to get 7% interest compounded quarterly. That's what the setup looks like. 200,000 is equal to P times 1 plus 0.07 over 4, all to the 4 times 30th power. 4 times 30 is 120. So once again, I'm taking each side and I'm dividing by this number. That number being 1 plus 0.07 over 4 to the 120th power. When I did that, I ended up with 24,940.20. The 19 rounds up to a 20 there. So just be careful about that. So present values and calculating present values is a pretty straightforward process. And most people are getting it well. The only thing you have to be careful on the test is reading carefully. Because sometimes, very often, people will read a present value, and instead of actually reading the question and saying, well, how much do you invest now to have 200,000 in the future? They'll read that and say, oh, I'm putting in 200,000 now. How much will I have in the future? Does that make sense? So just be very careful about reading those problems so that, you know, if you want 200,000 in the future, then it's your A, versus you're putting in 200,000 now, how much is going to be in the future, you're putting in the P. So just read that carefully, make sure you don't misread the problem. That's probably the biggest mistake that people make while they're taking the test, or primarily when they're taking the test, because in the homework, all of the present values are in the same section. Now, so far in our first few sections of interest, we've always been putting in the money and then gaining interest. Well, if you remember what the definition of interest was, it did deal with putting in money and gaining a certain value, but it also meant that if I take out a loan, I have to pay back extra value. And so we're going to talk about interest in debt, meaning if I take out a loan, how does interest work? Okay. So hopefully all of us understand what a loan is. It's this arrangement, usually with a bank, could be with someone, another party, but usually with a bank, where the bank gives me money and I promise to pay them back. But as I'm paying them back, I'm going to pay them back their own money plus interest. So when I bought a house, I took out a loan from the bank, and now I pay every month a certain amount. And part of that amount is interest, and part of that amount is what they call going down on your principal, how much you still owe. Right? We're going to see some other words too. Debt. Debt is how much I owe some person or some entity. And normally what happens on like a home loan or something is that interest is accrued on the remaining debt. So however much I owe on my house right now, interest is being accrued on how much I owe. Does that make sense? So interest is being calculated on how much debt I have left. I'm doing an example here. Assume I have a credit card on which I owe $2,000. Now, credit cards usually charge high interest rate. So let's assume the interest rate on that credit card is 24%. Compounded monthly. And so we're going to say after a month, be careful there, it's after 1 month. How much am I going to owe? And how much interest was accumulated? All right, so how much do you owe? How much do you owe in interest? We'll do the total amount that we owe and then the total amount of interest that's been accrued. Does that make sense? So if I owe $2,000, that's how much I owe right now in the present. That becomes the principal in my interest equation. Now the rate is pretty big. Like I said, credit cards generally have much higher interest rates than things like car loans or home loans or things of that nature. So this says 24% with a compounded monthly. Now here's the trick to this problem. We're only going to compound a month. Remember the T is in years, right? If we only compound for a month, how many years is that? Well, it's not even a year, right? It's a fraction of a year. It's actually 1/12 of a year, approximately. Get that. So technically what's going on here is that since we're compounding monthly for just a fraction of a year, for just 1 month, I'm going to take the 12 times the 1/12. It's probably easier thought of though by just saying how many compounding periods do I have? Well, if it's compounding monthly for a month, there's only one compounding period. Does that make sense? So if you're compounding monthly for a month, there's only one compounding period. You could also think of this as, yeah, n is 12 because it's monthly, but a month is 1/12 of a year. If you're okay dealing with fractions. I tend to think of it as this way. Compounding monthly for just a month, that's one compounding period. So we take the 2,000 and then multiply by 1 plus 0.24 over 12 to the first power. And then at the end of the month, the amount we owe is $2,040. Okay. Now, how much interest is accumulated? Well, if I owe 2,000 to begin with, and now I owe 2,040, the interest accumulated is $40, right? It's like interest gained, interest accumulated. That makes sense? Not too crazy. Now, oftentimes people have the misconception that when they pay on their credit card, the total of what they owe should be decreased by that same amount. Think about this. If you pay $60 on this credit card, what's going to happen is that $40 is going to go to at the end of the month. So you know at the beginning of the month you owe 2,000. You send in your check for 60. What's going to happen is you're going to still owe $1,980. Okay. So even though you sent in a check for $60, you're going to now owe $1,980. So that means even though you sent in for $60, the amount you owe only decreased by $20. Everybody follow that? And it's the same with houses. Oftentimes people will say, man, I sent in this check for $1,000 on my home mortgage, but it says I still owe, nearly the same amount. And that's true because most of that check went to principal. Or excuse me, most of the check went to interest and only a little bit went to paying down how much you owe. So paying down this principal. Does that make sense? So that's the basics of how interest and debt work. And I wanted to bring that up for that. Now, just as a thought experiment, if I only paid that $40 at the end of the month, then guess what's going to happen next month? The exact same thing. And if I just pay another $40 at the end of that month, and I just keep paying $40 every month, I'll never get out of debt. I'll always owe that $2,000. And you could do that forever, right? So if you just paid your $40 for 6 months, well, all of a sudden, you paid 6 times 40, which is 240 total dollars, and you didn't decrease your debt at all. That makes sense? Again, that's more of a thought experiment than anything. I want you to calculate this one. Assume we have a mortgage at 5% interest. And mortgages are typically done monthly, so let's assume we're compounding monthly. I owe $175,000 on mortgage. After a month, how much would I owe and how much interest would I owe in 1 month? Go ahead and try that one on your own. Again, compounded monthly. Assume we're compounding monthly because almost all loans are like on your mortgage or in a bank, most loans are monthly. Oh, no, this is 5%.
Oh,
Yeah. It would be though, you'd have it exactly right. I just need to change it. All right, so let me go through this. We owe $175,000 on mortgage. Interest is 5% compounded monthly. After a month, how much am I gonna owe? Well, again, owe $175,000, that is my principal of what I owe right now. We're gonna accumulate interest on that principal for a month. So you do 1 plus 0.05 divided by 12. The M, well, we're compounding monthly. We're going a month, so fraction of the year there. Or you can just think of that as 1 compounding period. Once you put that in your calculator at 1 compounding period, 1 month, the amount that I now owe on my house would be $175,729.17, rounded to 2 decimal places. That means in 1 month's time, the interest that I've accumulated is $729,000. I apologize. $729.17. Is that okay? Now, I did both of these initial 2 problems for a 1 month time period. So that we saw how that worked. Because oftentimes when you deal with the bank, you have to pay month by month, right? If you take out a home loan, if you take out a car loan, they make you pay month by month. There are other loans where you don't pay month by month, but you may wait a certain amount of time to pay your loan or to start paying your loan. Okay? Student loans are like that. Like while you're at college, you don't pay on them. And then when you get out of college, you have to start paying on your student loans. But oftentimes, depending on the process, oftentimes student loans are what they call deferred interest. They're accumulating interest even during the time you're not paying them. So let's pretend I have some sort of a loan like that. I have a loan of $34,000. So I owe $34,000. The interest on that loan is 6% compounded monthly. Let's say I don't have to pay anything on that loan for 4 years. After 4 years, how much would we owe on that loan? And then how much interest has accrued or accumulated? You can say either word after 4 years. How much do you owe after 4 years? How much interest is accrued after 4 years? Everybody okay with that? All right. And there it is. So we owe $34,000. That's my principal in this equation. We're going to do 6% interest monthly, so the M is 12 for 4 years. That means when I type this into my calculator, since it's 4 years, the T is just 4. That is 48 compounding periods. So 4 years is 48 months, right? So I just need to type that in just like we've done in every other scenario. And after 4 years, the amount that you would owe on that loan is $43,196.63. Let me rewrite that. If I take that number and subtract 34,000, that means $9,196.63 worth of interest has accrued or has accumulated. Does that make sense? Not too bad. So again, same calculation, but in depth. All right, same formula, but now we're in debt. By the way, this is one of the things that makes people upset. Oftentimes people will say, well, I have paid down my stupid college loans for, a decade and they don't look like they've changed very much. Well, this is why, because they keep accruing interest all the time. All right. So that's what's going on. By the way, just as a side note, remember the comparison we did earlier? And at the end, we said we want to invest as early as possible, get the best interest rate, and put in as much as we can afford. Well, if you flip that on its head, that's the advice for getting rid of your debt. You try to get the lowest interest rate possible. You start paying down your debt immediately, and you put as much down towards your principal as you can afford. Does that make sense? So you pay in as much as possible, and you try to get the lowest rate, and you try to pay that debt off as quickly as possible. That's kind of so that's the general takeaway for getting rid of debt as well. So just the flip side of that. So like I said before, you got 3 homeworks due, 2.0 through 2.2, that one. The present value of debt, that's what we did today. We'll start up with annuities next week. We will also have a test next week. I'll explain more about that on class next week, the first class of next week, which is Tuesday. So I'll explain more about the test and how that works. So don't go taking the test until, I talk to you about that Tuesday next week. Does that work? All right. Don't forget bonus homework if you want, also due on Friday for chapter 1. All right, other than that, I will see you all next week, Tuesday. Have a good weekend.